1967, the height of the Cold War. An isolated research facility in the Nevada desert, operated by the little-known agency Defense Atomic Support Agency, is about to become the site of the strangest experiment in Nevada history. The man behind this clandestine project was Dr. James Fletcher, a brilliant physicist and a key figure in the development of nuclear weapons during World War II. In the late 1950s, he began exploring the concept of nuclear isomer de-excitation, a phenomenon where certain atomic nuclei could be manipulated to release vast amounts of energy. Intriguingly, Dr. Fletcher's research was not classified or hidden from public scrutiny. Quite the contrary. His scientific papers were published in reputable journals and presented at prestigious conferences. However, his work gained little attention amidst the flurry of nuclear research during that era. Undeterred, Dr. Fletcher continued his investigations, convinced he was on the brink of a groundbreaking discovery. By 1967, he had assembled a team of top physicists at the Nevada site, now part of DASA's sprawling complex. Their mission, to create and control nuclear isomers, potentially unlocking limitless clean energy. The experiment they designed was as audacious as it was unprecedented. They planned to use high-energy particle beams to bombard a target made of metallic hafnium, an element known for its ability to form stable isomers. If successful, this process would trigger the isomer de-excitation on a macroscopic scale, releasing a tremendous burst of energy, theoretically enough to power a city for years. On that fateful day in 1967, all systems were go. The hafnium target was prepared, and the particle accelerator hummed with anticipation. As the countdown reached 0, the beam struck the target, and then something extraordinary happened. Instead of the expected explosion, there was a brief flash of light, followed by an eerie silence. The scientists rushed to analyze the data, but what they found made no sense. Not only had the hafnium not released the expected energy burst, it seemed entirely unaltered. Bewildered, Dr. Fletcher ordered another test. The results were identical. No matter how many times they repeated the experiment, the hafnium refused to yield its secret. Overwhelmed by this enigma, DASA quietly shut down the project and sealed off the lab, leaving behind a puzzling chapter in scientific history. Today, the mystery remains unsolved. Despite numerous attempts to replicate Dr. Fletcher's experiment, including those by renowned physicists like Carl Sagan, no one has been able to explain what occurred in that Nevada lab over half a century ago. The hafnium anomaly, as it came to be known, remains one of the most intriguing unsolved riddles in modern science. So join us as we delve deeper into this story, exploring its implications and pondering what might have been if only Dr. Fletcher's experiment had gone according to plan. Welcome to The Strangest Experiment in Nevada History, the discovery that started it all. Delve into the fascinating story of The Strangest Experiment in Nevada History. We must first explore the minds behind this enigmatic project. The experiment, known as the hafnium anomaly, was the brainchild of Dr. Elizabeth Fletcher, a nuclear physicist who made significant contributions to her field during her tenure at Los Alamos National Laboratory in New Mexico. Dr. Carm Ildia. Fletcher's fascination with hafnium, a transition metal often used as a control rod in nuclear reactors, began in the late 1960s. She observed unusual neutron absorption patterns in hafnium-278 that piqued her interest and set her on a path to uncover its secrets. With the support of Los Alamos National Laboratory and the United States Atomic Energy Commission, Dr. Fletcher initiated a series of groundbreaking experiments aimed at understanding these peculiarities. The team she assembled for this task was nothing short of extraordinary. Among them were Dr. Richard Langley, an expert in neutron physics from the Massachusetts Institute of Technology, and Dr. Jane Thompson, a theoretical physicist from the University of California, Berkeley. Together, they embarked on a journey to shed light on the hafnium anomaly. The experiments conducted by this team were as innovative as they were perplexing. Using advanced equipment such as the linear accelerator at Los Alamos National Laboratory, they fired high-energy protons at hafnium targets, measuring the resulting neutron emissions with exquisite precision. The data they collected revealed unexpected spikes in neutron production, which defied conventional understanding of nuclear reactions and left the scientific community both baffled and intrigued. Despite the team's collective expertise, the hafnium anomaly remained stubbornly unexplained. Dr. Fletcher and her colleagues proposed various theories to account for their observations, including the possibility of new, undiscovered particles or unanticipated nuclear reactions. However, none of these explanations could be definitively proven or disproven with the technology available at the time. The hafnium anomaly's implications were far-reaching and have continued to reverberate through the scientific community for decades. The experiment catalyzed new research into nuclear physics, neutron scattering, and materials science, inspiring a generation of physicists to push the boundaries of human knowledge in pursuit of answers. Today, the hafnium anomaly remains one of the most intriguing unsolved riddles in modern science. The questions it raises linger, teasing the minds of curious scientists who dare to explore the unknown. As we continue our investigation into this fascinating topic, we invite you to ponder what might have been if only Dr. Fletcher's experiment had gone according to plan. And so, the search for answers continues, fueled by the spirit of inquiry and the tantalizing allure of the unknown. 1979, in the heart of the Nevada desert, a clandestine project was underway, one that pushed the boundaries of what was considered possible in the realm of science and technology. Codenamed Project Flexible Anvil, it involved the construction of an experimental nuclear reactor with a twist. It was designed to be mobile, capable of being transported across vast distances by rail. At the helm of this daring endeavor was Dr. Harlan Fletcher, a brilliant physicist known for his unorthodox approach to problem solving. Funded by the Department of Energy and overseen by the Los Alamos National Laboratory, the project aimed to create a power source that could provide clean, efficient energy in remote locations. The technology behind this groundbreaking reactor was based on a concept called compact fusion. The idea was to harness the immense power generated by nuclear fusion, the same process that powers our sun, and contain it within a compact, transportable device. This was achieved through the use of advanced magnetic confinement, which allowed for the creation of a stable plasma core. But how did it work exactly? The reactor relied on a unique configuration of superconducting magnets to generate a powerful magnetic field. This field, in turn, contained and compressed a mixture of hydrogen isotopes until they fused, releasing vast amounts of energy in the form of heat. This heat was then used to produce steam, which drove a turbine connected to an electrical generator. The reactor's portability was made possible by its modular design. It consisted of several components that could be easily transported and assembled on-site, including the reactor core, the magnet system, and the cooling and power conversion systems. Once assembled, the entire unit could be loaded onto a specially designed rail car for transportation. Despite its innovative design and promising potential, Project Flexible Anvil was plagued by setbacks from the outset. The reactor's complex magnetic confinement system proved difficult to control, leading to numerous safety concerns and delays. Furthermore, the high cost of construction and operation made it a tough sell to both Congress and the public. And then there were the rumors, unsubstantiated claims that the project was actually a front for something far more sinister. Some speculated that it was an attempt to develop a new type of nuclear weapon, while others suggested that it was part of a secret government effort to achieve controlled nuclear fusion as a means of establishing global dominance. In the end, Project Flexible Anvil never lived up to its lofty expectations. Plagued by technical challenges and rising costs, the project was ultimately cancelled in 1983, a mere 4 years after it began. The reactor was disassembled and most of its components were scrapped, leaving behind little more than a few faded blueprints and a legacy of unanswered questions. To this day, the mysteries surrounding Project Flexible Anvil continue to captivate scientists and historians alike. Was it truly an ambitious attempt to revolutionize the way we produce energy, or was there something more to the story? Only time will tell if the truth behind this enigmatic chapter in our nation's scientific history ever comes to light. 1958, the height of the Cold War. As the world watched in fear and awe, two superpowers engaged in a high-stakes game of technological one-upmanship, each striving to outdo the other in a race for dominance that would shape global history for decades to come. In this climate of paranoia and ambition, the United States government embarked on a series of clandestine projects aimed at securing its position as the world's preeminent military and scientific force. One such project, known as Project Flexible Anvil, was conducted under the auspices of the Los Alamos National Laboratory in New Mexico. The details of this enigmatic endeavor remained shrouded in secrecy for over half a century, its files stamped with the highest level of classification and its researchers bound by strict oaths of silence. The project's objective was nothing less than revolutionary: to develop a new form of nuclear fusion that could be harnessed as a virtually limitless source of clean energy. The concept was breathtaking in its ambition, promising to render obsolete the fossil fuels that had powered human civilization for centuries and providing an unprecedented opportunity to reshape the geopolitical landscape. At the heart of Project Flexible Anvil lay a groundbreaking innovation: the use of powerful magnetic fields to compress and contain plasma, a state of matter composed of charged particles that exists at temperatures far beyond the reach of conventional materials. By confining this plasma within a carefully engineered magnetic bottle, scientists believed they could create a self-sustaining fusion reaction capable of generating staggering amounts of energy with minimal waste. But as the project progressed, it became clear that the challenges facing the researchers were far greater than anyone had anticipated. Despite their best efforts, they struggled to maintain the stability of the plasma long enough for a successful fusion reaction to occur. Time and again, their experiments ended in failure, with the plasma rapidly expanding beyond the confines of its magnetic prison and dissipating into the surrounding vacuum. It was during one such experiment that everything changed. On a fateful day in 1960, something went terribly wrong. The laboratory's records from that time are sparse and frustratingly vague, offering only tantalizing hints at the bizarre events that unfolded. What is known, however, is that an uncontrolled fusion reaction occurred, releasing a burst of energy that wreaked havoc on the laboratory's equipment and sent shockwaves through the scientific community. In the aftermath of the incident, Project Flexible Anvil was abruptly shut down, its files sealed away in a secret vault and its researchers scattered to the winds. The official explanation for the project's termination remains classified, leaving behind a trail of unanswered questions that has fueled speculation and conspiracy theories for generations. What really happened at Los Alamos on that fateful day in 1960? Did the scientists of Project Flexible Anvil succeed in their quest to unlock the secrets of nuclear fusion, only to have their discovery suppressed by a government desperate to maintain its grip on power? Or was there something more sinister at play, a catastrophic failure that threatened not only the future of the project, but the very fabric of reality itself? These questions may never be answered definitively, but as we continue to grapple with the challenges posed by climate change and the limits of our fossil fuel reserves, the story of Project Flexible Anvil serves as a poignant reminder of the boundless potential and profound risks inherent in humanity's quest for knowledge. In the vast desert landscape of Nevada, shrouded in secrecy and intrigue, lies a story that some would prefer remain untold. This is the tale of Project Flexible Anvil, an experiment so strange, so utterly perplexing, that it continues to baffle historians, scientists, and conspiracy theorists alike. The project was commissioned by the United States Department of Energy in the late 1970s with the specific aim of exploring novel methods for harnessing geothermal energy. Yet, the details surrounding its actual objectives and activities remain frustratingly elusive. What we do know is that a team of brilliant scientists, handpicked from various fields, was assembled under the leadership of Dr. Evelyn Shaw, an accomplished physicist with a storied career in government research. The project's clandestine nature is perhaps best exemplified by its location, a secluded underground facility nestled deep within the Nevada National Security Site, a former nuclear test site that remains largely off-limits to this day. Here, the team conducted their enigmatic research, shrouded in secrecy and surrounded by an impenetrable veil of national security concerns. But what exactly were they working on? The few documents that have managed to surface through the Freedom of Information Act offer only fleeting glimpses into the project's inner workings. They hint at experiments involving high-energy particle beams, exotic forms of matter, and even attempts to manipulate the very fabric of space-time itself. One particularly intriguing thread of inquiry revolves around the project's exploration of a then-emerging field of study, quantum mechanics. The team delved deep into the strange and counterintuitive world of subatomic particles, where things like superposition and entanglement challenge our everyday understanding of reality. Could it be that Project Flexible Anvil was secretly working on some form of quantum technology? Could they have stumbled upon a hidden truth, one so profound that it had to be suppressed for the sake of national security? The truth may never be known. The project was abruptly terminated in 1982, leaving behind a trail of unanswered questions and tantalizing mysteries. Its participants were either silenced or scattered to the winds, their lips forever sealed by non-disclosure agreements and veiled threats. But as we continue to grapple with the challenges posed by climate change and the limits of our fossil fuel reserves, the story of Project Flexible Anvil serves as a poignant reminder of the boundless potential and profound risks inherent in humanity's quest for knowledge. For beneath the surface of this strange tale lies a deeper truth, that our understanding of the universe is far from complete, and that there are still countless secrets waiting to be uncovered in the vast expanse of the unknown. As we've delved into the enigma of Project Flexible Anvil, one can't help but be left with a sense of wonder and intrigue. The questions that it raises are as compelling as the answers it withholds. Where does the responsibility lie in exploring potentially dangerous scientific frontiers? And what other secrets lie hidden in the annals of history, suppressed by governments or lost to time? The truth is, no one can say for certain. What we do know is that the Nevada National Security Site, where much of this research reportedly took place, remains an active facility for the Department of Energy, EDS. Its mission today revolves around managing the nation's nuclear weapons stockpile, ensuring their safety and reliability. However, given its past involvement in top-secret projects, it's not unreasonable to assume that there may be more untold stories lurking within its confines. Moreover, the key figures associated with Project Flexible Anvil have either moved on to other endeavors or remain shrouded in mystery. Dr. Dor En Ye, Raymond Bayless, whose work on psychokinetic phenomena was allegedly connected to the project, continued his research until his death in 2004. His extensive body of work, while controversial, contributed significantly to our understanding of parapsychology. Similarly, Los Alamos National Laboratory, another institution linked to these events, remains at the forefront of scientific discovery. As a multidisciplinary research center, it focuses on everything from national security to fundamental physics, making it a hotbed for cutting-edge science and technology. Yet, like many institutions dealing with sensitive information, much of what goes on behind its walls remains classified. Perhaps most intriguing is the fate of the so-called flexible anvil device itself. If indeed such a machine was developed, what became of it? Was it dismantled, stored away, or repurposed for other projects? These questions may never be answered, leaving us to wonder about the potential implications of this technology and its impact on our world. In closing, the story of Project Flexible Anvil serves as a tantalizing glimpse into the world of suppressed inventions and classified experiments. It reminds us that there are still many mysteries left to uncover in the realm of science, and that sometimes the most fascinating discoveries lie just beyond our reach. As we continue to push the boundaries of knowledge, let us not forget the lessons of the past, that with great power comes great responsibility, and that some secrets, once unlocked, can never be put back. For now, the truth behind Project Flexible Anvil remains elusive, a haunting reminder of the enigmatic path we have chosen to walk as explorers of the unknown.